we are the problem solvers and we are here to try to make math simpler for you. We are EM solver, PD solver, and AH solver. Today we will be showing you chapter 1 of Algebra 2. Hope you enjoy. To start off, we are going to begin by going over section 1.1, which is solving linear equations. Now, linear equations are usually in the form of ax plus b is equal to 0. The first example of solving a linear equation is 7x minus 5 is equal to 72. Now, to start off to solve this equation, you want to isolate the x by itself. So by doing so, you have to send the negative 5 to the other side in order to get 7x by itself. So you're going to be left with 7x is equal to 72 plus 5. Now the next step is to combine like terms, which will give you 7x is equal to 77. Now in order to get the x by itself, you have to undo the multiplication. So by doing so, you're going to divide by 7 on both sides. So you're left with x is equal to 11. And that's how you solve a linear equation. Now the next example is 11x minus parentheses 6x minus 5 close parentheses is equal to 40. Now the first thing you want to do is distributive property. Now here it's understood that you have a 1. So you bring down the 11x and you're going to distribute and multiply negative 1 to both of these terms. So you're going to be left with 11x minus 6x plus 5 is equal to 40. Now the next step is you want to combine like terms. Since here we have 11x and negative 6x, they both have an x, so you can easily just combine them and you're going to be left with 5x plus 5 is equal to 40. Now you want to do the same thing as we did in the first problem, so you're going to send over the 5 to the other side and you're going to be left with 5x is equal to 40 minus 5, which will give you 5x is equal to 35, and then you're going to divide by 5 on both sides and you're left with x is equal to 7. Okay. The next example is 5x minus parentheses 2x minus 10 close parentheses is equal to 35. So the first thing you want to do is distributive property again. So you're going to have 5x minus 2x plus 10 is equal to 35. So you want to combine the 5x and the negative 2x, which is going to give you 3x plus 10 is equal to 35. So you're going to send the positive 10 to the other side. You're going to do that. So 3x is equal to 25. Is equal to 25. Then you're going to divide by 3. And since you can't divide this, and that's the simplest way you can have the fraction, x is just equal to 25 over 3. The next example is 7 plus 3, parentheses x is equal to x minus 3 is equal to 2x plus 10. Okay, so the first thing you're going to do is distributive property again. So you're going to have 7 plus 3x minus 9 is equal to 2x plus 10. The first step is you're going to, what you want to do is you want to have all the same variables on each side. So you want to have the constants, which are 7, -9, and 10 on one side, and you want to have 2x and 3x on one side. So we're going to send these two terms to this side and this term to this side. So you're going to have 3x minus 2x is equal to negative 7 plus 9 plus 10. So then you're going to combine like terms, and you're going to have x is equal to 12.
What's up guys, this is PD Solver and we'll be going over section 1.2 complex numbers. First of all, what is a complex number? It's an imaginary unit identified as I, which is equal to a negative number inside a radical. So for example, negative 1 would be equal to I. Another note we have to know is that I squared is negative 1. For example, negative 25 squared is also equal to negative 1 times the radical of 25. So radical of negative 1 times radical of 25. So we know this is equal to I, and this is equal to 5. So in the end, to fix this, we have to have the number first, so it would be 5I. Next off, we will be adding and subtracting complex numbers. So if we have 5 minus 11I plus 7 plus 4I, the first step would be to remove the parentheses. So we would be left with 5 minus 11I plus 7 plus 4I. So we're going to consider I as a variable, so what we're going to do is we're going to combine like terms, and we'll simplify this to 12 minus 7I. That would be our final result once we combine like terms. Example number 2 on adding and subtracting. What we have is negative 5 plus I and negative 11. Sorry, that's a minus in the middle. Negative 11 minus 6I. First of all, since this is a negative, we want to distribute to change the signs. We will end up with negative 5 plus I plus 11 plus 6I, which once we simplify, combining like terms, we will end up with 6 plus 7I. That's how you add and subtract complex numbers. Second concept is multiplying complex numbers. So for example, if we have 4I, 3 minus 5I, we will be using distributive property, and once again we're going to consider I as a variable. So we would end up with 12I minus 20I squared. If you recall from the beginning, I squared is equal to negative 1. So what we will end up with is 12I minus 20 times negative 1, because I squared is equal to negative 1. So once we multiply, we will end up with 20 plus 12I after simplifying. Example, the next example we have is 7 minus 3I times negative 2 minus 5I. We will be using the FOIL method, so we will have negative 14 minus 35I plus 6I plus 15I squared. Once again, I squared is equal to negative 1, so it will be negative 14 minus, this is a 5, my bad, 35I plus 6I plus 15, and then our I squared is negative 1. After simplifying all of this, our final result will be 29 minus 29I. negative 29. Okay. Next we will be going into dividing complex numbers. So if we have 7 plus 4i over 2 minus 5i, what we will be using is the conjugate. What is the conjugate? The conjugate is our denominator with the opposite sign. So we will end up with 2 plus 5i over 2 plus 5i. This is our conjugate. It's our denominator with the opposite sign. What we will do now is we will multiply across, and we will end up with 7 plus 4i times 2 plus 5i over 2 minus 5i, 2 plus 5i. What we will do is we will use the FOIL method, and our final result will be negative 6 plus 43i over 29. The next concept we will be learning is roots of negative numbers. For example, if we have negative b instead of radical, it will be equal to I radical b. So, if we have radical negative 25 times radical negative 4, this would be equal to I radical 25 times I radical 4. Once we simplify this, it will be I 5 or 5i. So this is the proper way is to write it as 5i times 2i. Once we multiply this, we end up with 10i squared. Once again, I squared is negative 1, so 10 times negative 1. Our final result is negative 10. Very simple. Next concept we will be going over is operations involving square roots of negative numbers. So basically operations involving imaginary numbers, or our i's. So if we have negative 25 plus radical of negative 50 over 15, this is our problem. To solve it, we will have negative 25. Applying the concepts we learned, it would be I inside radical of 50 over 15. Then we will have negative 25 plus 5i times radical of 2. Because radical of 50, we can simplify it into radical of 25 times 2, which is also equal to 5 radical 2. This is why we ended up with this. All of this is over 15. So then once we write this in standard form, it will be negative 25 over 15 plus 5i over radical 2 over 15. Of radical 2 times radical 2 over 15. So our final result would be negative 5 over 3 plus I over radical 2 over 3. That's a simple operation involving complex numbers. Here is some practice so we can review. So 7 plus 4i and 7 minus 4i. This is multiplying complex numbers. We will use FOIL. After using FOIL, we will have 49 minus 28i plus 28i minus 16i squared. These two will convert into nothing, to 0. So these will cancel out. Now we will be practicing what we have learned into these two problems. So 7 plus 4i times 7 minus 4i. This is the FOIL method. This is multiplying complex numbers. So we would end up with 49 minus 28i plus 28i minus 16i squared. We know this will convert into 0. So it would be 49 minus 16i squared. From background information, we know I squared is equal to negative 1. So it will be 49 minus 16 times negative 1. Our final result after simplifying would be 65. example number 10, which is dividing. So we have 1 over 7 plus 4i. Once again, we use the conjugate. What is the conjugate? It'll be this operation with the opposite sign being divided by itself. So 7 minus 4i over 7 minus 4i. Once we have our conjugate, we will multiply. So we would end up with 1 times 7 minus 4i over 7 plus 4i times 7 minus 4i. We will multiply, so we would end up with 7 minus 4i over 49 minus 28i plus 28i minus 16i squared. Once again, this will convert into 0, so we would end up with 7 minus 4i over 49 minus 16i squared. We know I squared is equal to -1, so 7 minus 4i over 49 minus 16 times -1. We will have 7 minus 4i over 49 plus 16, which is 7 minus 4i over 65. Once we write this in standard form, our final result would be 7 over 65 minus 4i over 65. And that's all you have to know on complex numbers for chapter 1.
Hi guys, I'm AH Solver, and today I'll teach you section 1.3, which is solving quadratic equations with a quadratic formula. First of all, what you need to know is that a quadratic equation in X is an equation that can be written in the general form ax squared plus bx plus c equals to 0, where a, b, and c are real numbers and a does not equal to 0. The quadratic equation is an equation for parabolas. When we solve for x in an equation, we are solving for the roots. So you'd be solving for the roots that intersect the x-axis. The quadratic formula that we used to solve for solving is x equals -b plus minus square root of b squared minus 4a times c over 2 times a. So the first example would be x squared plus 8x plus 15 equals to 0. So when we are solving, we have to input the numbers. So this would be a, this would be b, and this would be c. Here, since there's no number in front of x, we use number 1. So then x equals to 8, -8 plus minus the square root of 8 squared minus 4 times 1 times 15 over 2 times 1. So then x equals to -8 plus minus the square root of 64. 4 times 1 is 4, 4 times 15 is 60, minus 60 over 2. Then be -8 plus minus square root of -4. And then over 2, -8 plus minus over 2, and the square root of 4 will be 2, so it'll be 2 over 2. And then this would be -4 plus minus 1. So then it'd be x equals to -4 plus 1, and x equals to -4 minus 1. This would be -5, and this would be -3. So x is equals a set of -5 and -3.
This would be your answer. Example number 2. X squared plus 5x plus 3 equals to 0. We use the quadratic formula once again, and a 1 goes before the x squared. So x equals b, which is 5, negative 5 plus minus square root of 5 squared minus 4 times 1 times 3 over 2 times 1. This equals negative 5 plus minus the square root of 25 minus 4 times 1 is 4 times 3 is 12 over 2. This would equal negative 5 plus minus the square root of 13 over 2. Our final answer would be x equals a set of negative 15 minus the square root of 13 over 2 and negative 5 plus the square root of 13 over 2. Example number 3 will be 3x squared minus 3x minus 4 equals to 0. We have x equals, so here since it's a negative it will be a positive 3 since it's minus b, plus minus negative 3 squared minus 4 times 3 times negative 4, which is c, over 2 times 3. This would equal to square root of 9 minus 4 times 3 is 12 minus 4 is positive 48 because it's minus, it's a negative and a negative will equal to positive over 6, and x would equal to 3 plus minus 57 over 6. And the 6 goes for both. So then we have x is equal to a set of 1.5 minus the square root of 57 over 6 and 1.5 plus square root of 57 over 6. Example number 4. Be x squared plus 5x plus 2 equals to 0. So then b is 5 minus 5 plus minus b squared, which is 5 squared, minus 4 times a, which is 1, and times c, which is 2, over 2 times 1, 2 times a. X equals negative 5 plus minus the square root of 25 minus 8 over 2. So then x equals negative 5 minus the square root of 17, because 25 minus 8 is 17, over 2, and negative 5 plus 17, the radical of 17, sorry, but over 2 is set off. Example number 5, 4x squared equals 2x plus 7. So here what you want to do is have it equal to 0. So try to prevent having a negative here. So it will be 4x squared minus 2x minus 7, because you transfer this to this side, equals to 0. And it'll be x equals 2 plus minus, well, the square root of negative 2 squared minus 4 times 4 times 7 over 2 times 4. And then x equals 2 plus minus 4 minus 16 times 7 will be negative 112 over 8, and then it's x equals 2 plus minus 4 plus 112 over 8 because there are two negatives. And this will equal to x equals 2 plus minus square root of 116 over 8. Then you would have to separate the radicals. Just 2 plus minus is radical 4 times radical 29. X equals 2 plus minus the square root of 4 is 2 times the square root of 29, both over 8. X equals 1 over 4 plus minus the square root of 29 over 4. So our final answer will be x equals a set of 1 minus the square root of 29 over 4 and 1 plus the square root of 29 over 4. Okay, so since you should have the idea by now, example, I'll just do 2 more examples. So example number 6 would be 3x squared equals 6x minus 1. Then you have to move these to the left. So it'll be 3x squared minus 6x plus 1 equals to 0. So then 6 plus minus negative 6 squared minus 4 times 3 times 1 over 2 times 3. So then once you simplify everything, we'd have 6 plus minus the square root of 24 over 6, which would equal to 6 over 6 plus minus the square root of 24 over 6. X equals 1 plus minus, and then here we separate the radicals. Then x equals 1 plus minus 2 radical 6 over 6. X equals 1 plus minus 1 radical 6 over 3 since we simplified 2 over 6. And x will equal a set of 1 minus the radical of 6 over 3 and 1 plus radical of 6 over 3. Example number 7, the last example. We're going to use one that includes i's. So it will be x squared minus 6x plus 10 equals to 0. X equals to 6 plus minus the square root negative 6 over 2 minus 4 times 1 times 10 over 2 times 1. So then x, once you simplify everything, you'd have x plus minus the square root of negative 4 over 2. So what you're going to do here, you're going to do the same thing and separate the radicals. Will be radical of 4 and radical of negative 1 over 2. So then x will equal to 6 over 2 plus minus the radical of 4 will be 2 over 2 and square root of negative 1. And then it will be x equals 3 plus minus 2 radical negative 1 over 2. Then x will equal to 3 plus minus 2 over 2 cancel out, and you'll have negative 1. So once you put it on set notation, x will equal to the set of 3 plus I and 3 minus I, since the radical of negative 1 is I. And that concludes the section 1.3 quadratic equations.
What's up guys, this is PD Solver again, and we will be going over section 1.4 factoring.
So the first concept we're going to go over is very simple. For example, let's say we have x squared plus 6x is equal to 0. This can only be done when you have a leading coefficient of 1. So what we're going to do is we're going to factor out the greatest common factor, which is x, and x plus 6. So when we multiply this, it'll give us the beginning formula. So this is one factor and this is the other. We will set both of them equal to 0. So x is equal to 0 and x plus 6 is equal to 0. We will move the 6 over and we will have x is equal to negative 6. So in the end, we will have x is equal to the set of negative 6 and 0. I would like to note that you want to put the least you want to order this from least to greatest. The next concept we will be going over is grouping. Let's say we have x squared minus 3x minus 10 is equal to 0. What we want to do is we want to multiply these two digits, the leading coefficient and the last number, our c, and this will give us negative 10. Our goal now is to get two digits that will give us, when multiplied, that will give us this number, and when added will give us this number. So let's try negative 5 and 2. Negative 5 times 2 is negative 10, so that would work. And negative 5 plus 2 equals to negative 3, which is this digit, so that would also work. Next, we'll replace these numbers and put them in the middle of our formula in place of the 3 in this manner. So it would be x squared minus 5x plus 2x minus 10 is equal to 0. Now we will group like so, and we will take out the greatest common factor. So our greatest common factor here is x. So we will have times x minus 5. So when we distribute it, we will get this one. We will factor out 2 on this side, and we will get x minus 5 on the inside is equal to 0. Our next step here is to combine these two, and these two are the same. If you notice, that's our goal, to get these two factors the same. So what we will do now is combine these two, so this would be x plus 2, since this is a positive, that's one factor, and these two are the same, like I repeated, so we will only copy this factor down once again. So x minus 5. I want to show you guys a trick at this point. So if you notice, this plus 2 and minus 5 is the same thing as our first two digits that we got. So what we could do, only when our leading coefficient is 1, is move the first two digits, which are these two, and just put them into our factors already. But this can only be done when our leading coefficient is 1. So once again, we have these, and we will set them both equal to 0, and we will get our solutions, our roots. So x plus 2 is equal to 0, and x minus 5 is equal to 0. So x is equal to negative 2, and x is equal to positive 5. So our final results will be x is equal to the set of negative 2 and 5. Alright. The next concept we will be going over is completing the square. Let's say you get x squared plus 8x. Easy, we can do the first concept we learned today. But let's say the instructions say to solve by grouping. Well, we don't have a c, we have a binomial. What we will do now is we will complete the square. This formula is in the form of x squared plus mx. So this is equal to this, and this is equal to this. What we want to do to make it a trinomial is we want to add m over 2 squared to the entire formula. So we would get our m over 2 squared is 8 over 2 squared, because this is the same thing as this. Our m is 8. So once we add this to our entire formula, we would get x squared plus 8x plus 8 over 2 squared. Once we simplify, our final result would be x squared plus 8x plus 16. Now we have a trinomial allowing us to use grouping. So now that we have all three concepts down, all we're going to do is do some practice questions. So let's say we have x squared minus 13x plus 36. We will multiply these two digits and we will get 36. After getting all the factors, we will realize that -4 and -9 are the two factors that we will be using to solve this equation. So we will have x squared minus 4x. That's our one group, and then minus 9x plus 36. That's our other group. We factor out the greatest common factor. These two are the same, so we did it correctly. X minus 9. Once we put these together, these two are the same, so we only copy it down once. To get our final results, we set them both equal to 0, and our final results will be x is equal to the set of 4, 9. Another example. X squared is equal to -11 minus 10. 11x. My bad. So we want to set this equal to 0, so we're gonna move all of these over to this side. So we will end up with x squared plus 11x plus 10 is equal to 0. Once again, we will multiply, get the factors that fit. So 1 and 10 fit perfectly. So we will have x squared plus 1x plus 10x plus 10. We will group, and we would have take out the greatest common factor. To get a final result of x is equal to the set of -10 and -1.
Well, that's it for today, guys. Well, give us a big thumbs up, and if you haven't clicked that subscribe button, please go click it now for more problem-solving videos. Thank you.